Okay, Wildcats, today we're looking at Thursday, January 11th, Quadratic Inequalities, and that's going to be on page 44. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at your notes. All right, Quadratic Inequalities on page 44. Graphing quadratic inequality steps. Step 1, graph the parabola using the X-Intercepts and the vertex. Step 2, use a solid parabola for y is less than or equal to and y is greater than or equal to, and a dashed parabola for y is less than and y is greater than. Step 3, shade above the parabola for y is greater than and y is greater than or equal to, and shade below the parabola for y is less than and y is less than or equal to. All right, so if you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, example number 1. And can't forget page 44. All right, so first step, we're going to find the X-intercepts. All right, so intercepts are the 0, so we said the right side equal to 0. So 2x squared minus 4x minus 6 equal to 0. Now, whenever factoring, you look to find the greatest common factor first. In this case, it looks like it is 2. So we're actually going to divide everything by 2. So 2x squared divided by 2 is 1x squared. Minus 4 divided by 2 is 2x. And then negative 6 divided by 2 is minus 3. And 0 divided by 2 is 0. So now we're going to look to see if it's factorable. So we look at all the combinations to make negative 3. So we know that 1 times negative 3 and 3 times negative 1. So we look for now which combination gives us negative 2. And in this case, it looks like 1 and negative 3. So now we factor using the box method. All right, first term, last term. So we know x and x make 1x squared. We're looking to get negative 2x. So we know that plus 1 and minus 3. So 1x, negative 3x. So they combine to be negative 2x. So our factors are x plus 1, x minus 3, equal to 0. So we said x plus 1 equal to 0, and x minus 3 equal to 0. So we subtract 1 from both sides, so x equals negative 1. And add 3 to both sides, so x equals 3. All right, so we're just going to put an approximate sketch on the graph. So negative 1's probably about right here. And 3's probably about right here. Which those are actually open circles because there's no line underneath. All right, so next we're going to find the vertex. All right, to find the vertex, we know that h equals negative b divided by 2a. And for that, I'm going to go back to the original inequality. So b is negative 4, so that's negative 4 divided by 2 times a, which is 2. So that's a positive 4 divided by 4 is a positive 1. To find the k value, you plug the 1 back into the right side, so that's 2 times 1 squared minus 4 times 1 minus 6, which makes k equal -8. So your vertex is 1, comma, -8. And so then that's 1, -8 is about right here. So let me section off the vertex work. All right, so now there's no line in these, so we know it's a dashed line. And since it's less than, we shade below. All right, now remember, as we're going through examples, if you get stuck at any point in examples, you can stop, circle, or put a note, and then I can go back over that example in class. But if you understand them, we keep going, just keep following along with me, okay? All right, so now let's look at example 2. All right, first thing is we're going to find the X-intercepts. So we set those, the right side equal to 0, because the X-intercepts are the zeros. All right, so then we find all the combinations that make -2, so which we know are 1 and -2 and 2 and -1. Now, because of the 2 in front of the X, we can't just look to see if the combination is -5. We actually have to look at it with the box. So first term, last term. Now we know the only combination to make 2x is 2x and 1x. And the reason why I have you list all the factors is because we need to try every combination here to see if it's factorable. So we're going to put a +1 and -2. And remember, our goal is -5x. Okay, so that's 2x, -2x. That equals 0, not -5x. So that combination doesn't work. So now let's try -2 here and +1 here. So then that's -4x, 1x. That combination doesn't give you -5x, so that one doesn't work. Okay, so now let's try +2 -1. That's 4x, -1x. Still not -5x, so that doesn't work. So now let's try -1 and a +2. So then that's -2x and then 2x. That's 0x, not -5x. We've gone through every combination. We now know it's not factorable. So if it's not factorable, then you're going to use the quadratic formula to find the zeros. So we go back here and we know that A is 2, B is -5, C is -2. So X equals -5 plus or minus the square root of, now remember, when you square negative, it has to be in parentheses. So -5 squared minus 4 times 2 times -2 divided by 2 times a is 2. So we have x equals a positive 5 plus or minus 5 squared minus 4 times 2 times negative 2 is 41. And then 2 times 2 is 4. So then we have x equals 5 plus the square root of 41 divided by 4, and x equals 5 minus the square root of 41 divided by 4. So x equals 2.851. And x equals negative 0.351. All right, so now let's just sketch those. So this is probably where x equals negative 0.351. It doesn't have to be exact, it's approximate. And then here's good point. And these are solid dots because there's a line underneath. X equals 2.851. All right, now we find the vertex. Now to find the vertex, we know that h equals negative b divided by 2a. So that's negative 5 divided by 2 times a, which is 2, which is a positive 5/4, which we know as a decimal is 1.25. Now, once you found h, to find k, we plug 1.25 back into the right, so that's 2 times 1.25 squared minus 5 times 1.25 minus 2. So k equals negative 5.125. So your vertex, which we'll note as v, is 1.25 times negative 5.125. I'm going to label that. So 1.25 negative, it's about right here. That's your vertex. There's a line underneath, so we know it's a solid line. And since it's greater than, we shade above. All right, so go ahead and finish up example 2, or note some questions you have, and I can go over that in class again, okay? All right, now let's look at example 3. All right, solve each inequality and show the solution on a number line. So in here, we're just graphing on the number line, okay? But same steps as before, except for this one, we don't need the vertex, okay? And I'll explain why in a second. So here, we need to set this equal to 0. So we're going to actually add 1 to both sides. So we have 2x squared plus 3x plus 1. And we're just going to set it equal to 0 because we're finding the x-intercepts, and the x-intercepts are the zeros. All right. It was in your eyes. The screen was actually blurry. All right. So again, we're going to factor. So we look at all the combinations and make 1. Well, that's just 1 times 1. Okay. So now we'll draw our box. first term, last term. All right, so we know the only combination to make 2x squared is 2x and 1x. And the only possible combination is 1 and 1, so we're going to try 1 and 1. So plus 1, plus 1. And we know it's factorable if we get the combination of 3x here. Okay? All right, so 2x times 1 is 2x. 1 times 1x is 1x. These combine to be 3x, so this is factorable, and our factors are 1x plus 1 and 2x plus 1. And that's equal to 0. All right, so we set 1x plus 1 equal to 0, and 2x plus 1 equal to 0. So we subtract 1 from both sides, so 1x equals negative 1. And subtract 1 divided by 2, x equals negative 1/2. All right, so whenever I draw a number line, I always put 0. So I know that the negatives are on the left, the positives on the right. But I just noticed that they're both negative, so I'm actually going to move my 0 from the middle to the far right. Okay. Now, there's no line underneath, so these are open circles. So we have an open circle at negative 1/2, and we have an open circle at negative 1. I move this. Let's just put it right here. Okay. Now, here we don't need the vertex for this reason. We're just graphing it on the number line, but we need to know if it's going up or down. Well, since this is positive, the a value is positive, we know that the graph is going up. And it's a dashed line here. Okay. Now to understand where we shade on the number line, we look at it like this. Since it's less than, we look at where's the graph below. Well, it's this piece right here. Since this piece is below and it lies between here and here on the number line, we know we're shading here. Okay, and if you want to, you could redraw this if you don't have to. So there's our solution on the number line. All right, and again, if you had questions on that, you could just kind of put a note there and remind me. I'll go back over that in class. If not, let's go. If you understood it, let's move on to example 4. All right, example 4. So same thing, we need to move everything to one side, so we're going to subtract 3, so we get x squared plus 5x minus 3 equal to 0. So we're looking at, to see if we can factor, we look at all the combinations make negative 3. So 1 times negative 3, 3 times negative 1. None of these will combine to be a positive 5x, so we know this is not factorable. So we're going to solve using the quadratic formula. So A is 1, B is 5, C is negative 3. So x equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 3. That was a bell. It's an interesting factoid about the bells at school. I don't think they work when the temperatures go below 20 degrees. So then 2 times 1. So then x equals -5 plus or minus the square root of 5 squared minus 4 times -3 is 37 divided by 2. So then x equals -5 plus the square root of 37 divided by 2, and x equals -5 minus the square root of 37 divided by 2. So we simplify it to the decimal, or approximate to the decimal, I should say. X equals 0.541, and x equals -5.541. All right, so again, we put 0. We know that 0.51 is a closed circle because it's a line underneath, so that's 0.5. This would be a 441, and -5.541. Since, again, A is positive, we know the parabola opens upwards. Okay, and in this case, it's greater than. We look at where in the graph is it going to be above. So here, this between it's all below. So we don't shade there, but on the outside, on the left and right, it's above. So we shade on the left and right. So your sketch would look like this. So you shade on the left and the right. So with that, at this point, you have two options. If you understood the example, start working on the assignment. If you didn't, just wait to class to ask some questions on the examples, and then start the assignment in class. And as always, have a wonderful Wildcat